The biting wind, a relentless sculptor of granite and breath, howled a glacial symphony around the solitary figure perched precariously on the apex of that nameless peak, a monolith thrusting its stone shoulder into the indifferent cosmos. Night had draped itself over the world, a velvet so profound it seemed to absorb sound itself, yet the air was a roaring chorus against the eardrums, whispers laced with the infinite cold of altitudes where the atmosphere thins to nothingness. Above, the vault of the heavens was not merely dark, but an abyss saturated with the diamonds of 10,000 billion distant suns, each a pinprick of ancient, struggling light. It was in this profound, chilling stillness, this communion with the absolute scale of existence, that the thought took root, nourished by the sheer, overwhelming spectacle above, the notion of the cosmic grand library hidden within the most violent messengers of the universe, the gamma rays. These gamma rays, unseen by the naked eye, are the ultimate expression of electromagnetic fury, photons boasting energies that eclipse even the most aggressive X-rays by factors of 1,000, 10,000, sometimes millions. They are not the gentle, lingering light of common stars, they are the death cries, the birth announcements, the final, cataclysmic punctuation marks written across the fabric of space-time. They originate from the universe's most extreme laboratories, the final, agonizing collapse of stars far more massive than our sun into singularities, black holes, or, perhaps more spectacularly, the head-on, ultra-relativistic collision of two neutron stars, remnants of supernovae so dense that a mere teaspoonful would outweigh Mount Everest. Picture the physics. The iron heart of a star, having exhausted its nuclear fuel, succumbs not with a whimper, but with a gravitational implosion so swift that the core collapses faster than the speed of light can travel across its own diameter, creating a space-time curvature so intense it warps the very notion of reality, resulting in a hypernova or a merging event that unleashes a beam of focused energy capable of sterilization across light years. These beams, these gamma-ray bursts, or GRBs, scream across the intervening void at the ultimate speed limit, the speed of light, carrying kinetic and radiant energy that, were one precisely aimed at our pale blue dot, would scour the surface clean in an instant, reducing oceans to steam. Mercifully, they are mostly wide-flung, traversing the eons only to kiss the detectors of our terrestrial sentinels. And here lies the fascinating pivot from raw astrophysics to speculative, yet deeply rooted, cosmic archaeology, the idea that these brief, brilliant flashes are more than just explosive aftermath, that they are the universe's own historical archive, a library of primordial data encoded in transient, high-energy events. The very existence of GRBs was first serendipitously discovered not by astronomers seeking stellar demise, but by military satellites, the Vela series in the 1960s, ostensibly designed to monitor clandestine nuclear tests on Earth. Imagine the scene, the sterile, humming environment of a Cold War monitoring station, radar screens flickering with mundane terrestrial data, when suddenly, an anomalous spike, a signature utterly alien to terrestrial physics, pierced the background noise. The sheer bewilderment, the dawning realization that these signals originated from deep space, shattered prior assumptions about the quiescent nature of the cosmos. Fast forward to the present era, specifically the year 2025. The Fermi Gamma-Ray Space Telescope, a masterful orbital observatory, has catalogued thousands of these events. Crucially, many identified GRBs boast redshifts, a measure of cosmic recession due to the expansion of space, indicating travel times spanning billions of years. Some signal origins trace back to an epoch when the universe was merely a few 100 million years old, a toddler in cosmic terms, witnessing the very first generation of stars ignite. To conceive that we are receiving light, energy packets, that began their journey when the universe was barely out of its dark ages, is profoundly moving. It is holding a photon that witnessed history firsthand. The analogy of the library is potent because a library is not merely a collection of random pages, but an organized repository of information, structure, and meaning. Gamma-ray spectra, when meticulously analyzed by instruments like the Neil Gorell's Swift Observatory, function as fingerprints. When a GRB erupts, the energy profile, the specific distribution of photon energies across the electromagnetic spectrum, provides clues about the engine driving the blast, the density of the surrounding interstellar medium, and even the composition of the stellar progenitor. It is a reconstruction of an event, a reverse engineering of cosmic catastrophe. We are, effectively, reading the aftermath of implosions that occurred when galaxies were just beginning to coalesce. Consider the hypothetical discovery of traces of primordial dark matter interactions embedded within the residual energy signatures of a very distant, very powerful GRB. Dark matter, that invisible scaffolding constituting approximately 85% of the universe's mass budget, remains stubbornly undetectable except through its gravitational influence. If a GRB originating from the early universe displayed an energy signature inconsistent with standard baryonic matter interactions, perhaps revealing the decay or annihilation products of dark matter particles, it would be the definitive text revealing the nature of this elusive substance. Indeed, the year 2025 brought whispers of such a monumental find. Data analysis from the Fermi instrument, cross-referenced with ground-based observations, hinted at an unusual, persistent gamma-ray excess emanating from the core of the Milky Way, a signal first hinted at as early as 2009, which had remained an enigmatic feature for nearly 17 years. Leading astrophysicists, their usual professional detachment momentarily cracked by sheer intellectual exhilaration, described the atmosphere in the analysis rooms, the hurried scribbling, the spilled coffee, the sudden, stunned silence followed by applause, as electric. This diffuse, enduring signal might be the first tangible proof of dark matter interaction, a spectral ghost finally revealing itself, carrying encrypted knowledge about the initial conditions of cosmic structure formation. But the library concept invites a deeper, more provocative question: is this information merely recorded? Naturally, or could it be encoded? Deliberately? This is where the scientific narrative skirts the edge of hard science and enters the realm of astrobiological speculation, a boundary thrillingly illuminated by the ongoing search for extraterrestrial intelligence, or SETI. The proponents of this idea reason from the robustness of the messenger. Gamma rays are fantastically penetrating. They slice through the cosmic dust clouds, the nebulae, and the intergalactic medium that readily absorbs or scatters lower-energy photons like visible light or radio waves. If a civilization, vastly older and more technologically advanced than ours, faced an inescapable, sudden demise, perhaps a local gamma-ray burst triggered by a nearby stellar event, an apocalypse painted across their sky in unimaginable hues of energy, what would be their final act of legacy? If they possessed the means to manipulate the fundamental forces of nature on a stellar scale, an artificial manipulation of core collapse mechanics, or the focused annihilation of exotic matter, could they generate an engineered GRB? This engineered burst would function as the ultimate message in a bottle, a concentrated burst of information projected across the light cone of spacetime, intended to survive cosmological timescales. By 2025, the capabilities of the James Webb Space Telescope, observing in the infrared but sensitive enough to catch afterglows and precursor emissions, were leveraged in conjunction with transient radio observatories. Reports circulated regarding the detection of ultra-high-energy gamma signatures traced back to a galaxy 7.6 billion light-years distant. Janna Levin, the renowned cosmologist, reportedly felt a physical quickening of pulse upon reviewing the preliminary data, as these specific energy profiles deviated from known stellar collapse models. The quiet, rhythmic beeping of the data acquisition systems suddenly sounded less like machinery and more like a deliberate Morse code tapping from the deep past, evoking that poignant tension between cosmic isolation and the desperate human yearning for connection. Expanding our understanding with the latest simulations available in 2025 reveals intriguing natural mechanisms that mimic complexity. Researchers at the Max Planck Institute for Astrophysics in Garching, Germany, utilizing exascale computing clusters, machines capable of performing quintillions of calculations per second, have run sophisticated hydrodynamic and magnetohydrodynamic simulations of galactic mergers and primordial structure evolution. Their models suggested that specific shockwave interactions occurring during the collision of dark matter halos with the very first clouds of baryonic matter might produce gamma-ray fluxes that possess a higher degree of informational entropy, or pattern, than random thermal emissions. Visualize these simulations: glowing supercomputer halls filled with technicians watching trillions of particles interact in dark, simulated space, the resulting energy releases manifesting as controlled, dazzling cosmic fireworks that could be the echoes of the universe emerging from the cosmic dark ages, the period preceding the first stars. Further compounding this picture, A parallel research effort from Tsinghua University in China focused on identifying progenitor systems for population 3 stars, the theorized, metal-free first stars. They pinpointed a faint, gravitationally lensed system designated miles per gallon CR3, nearly 11 billion light-years distant, which appears to be hosting these massive, short-lived stellar giants. The analysis strongly suggests that the resultant gamma emissions from their rapid demise carry the spectral imprint of nearly pure hydrogen and helium, the universe's original building blocks, offering a pristine record of nucleosynthesis before heavier elements polluted the cosmos. The sheer inspiration derived from this data feels akin to witnessing a genuine cosmic sunrise, the initial, frozen silence of pre-stellar existence gradually warming under the incandescent light of creation. To ground this abstract cosmic narrative, one must reflect on how our ancestors perceived these celestial outbursts, long before we understood photons or redshifts. Millennia ago, in the Fertile Crescent where Sumer and Babylon arose, civilizations gazed upward, interpreting celestial anomalies, streaks of fire, sudden brilliance in fixed stars, as divine pronouncements or omens. They erected ziggurats, stepped pyramids of baked earth and mud brick, designed explicitly to minimize the atmospheric barrier between themselves and the heavens, hoping to physically elevate their priests closer to the source of perceived knowledge. These Mesopotamian astronomers were the pioneers, meticulously charting planetary movements on clay tablets. It is plausible, even probable, that the occasional, unaccounted-for brilliant flare they recorded, a new star that quickly faded, was in fact the light curve of a nearby, albeit weaker, GRB. Similarly, ancient Chinese astronomical records frequently document guest stars or dot caching, sudden arrivals in the celestial sphere, often supernovae or comets, but the sheer intensity implied by some descriptions might account for more energetic events. These historical echoes provide a comforting continuity. Despite the technological chasm separating a Babylonian scribe from a modern particle astrophysicist operating orbital telescopes, the fundamental human drive, the desperate, unshakable need to read the script written in the sky, remains invariant. The narrative of discovery is perpetually unfolding, and updates towards the close of 2025 provided fresh impetus for the cosmic library hypothesis. At the site of the Vera C. Rubin Observatory in the Chilean high desert, whose unparalleled survey power is now fully operational, a team detected a vast, ephemeral structure in the deep sky, a filamentary alignment of matter spanning angular distances that, when redshift corrected, suggested a physical length exceeding the diameter of the Milky Way itself. Moritz Mikkel-Muru, a key data analyst, reportedly expressed near uncontrollable excitement, the digital alerts from the survey software echoing like bells in the otherwise quiet control room, suggesting this structure might be the lingering gravitational wake, or perhaps the energy dissipation shell, related to an exceptionally ancient, powerful GRB that seeded the environment for subsequent galaxy formation. Concurrently, the ongoing long-term monitoring by Fermi's all-sky instruments revealed that a specific subset of long-duration GRBs exhibited energy release characteristics consistent with models where the formation of the central engine, the nascent black hole, is profoundly affected by the equation of state of exotic matter or, more tantalizingly, the rapid expansion driven by dark energy. Imagine drifting through the intergalactic void, feeling that pervasive, unseen force pushing everything apart, an empty space simultaneously brimming with potent, mysterious energy. These findings suggest that gamma rays are not merely relics of the past but active participants in shaping the universe's fate, implying that by decoding their patterns, we might unlock the very mechanism of cosmic acceleration. This transforms the library from a mere repository into an active, evolving manuscript. The human element is crucial to lending emotional resonance to these vast, cold numbers. Recall the quiet intensity of Stephen Hawking, confined by his motor neuron disease, yet whose eyes shone with undimmed intellectual fire as he postulated the information paradoxes surrounding black holes and the nature of energetic emissions. He was a conduit, translating the ineffable complexity of the universe into terms that inspired generations. Today, the new cohort of researchers, often operating on meager grant funding but fueled by an almost spiritual devotion to the unknown, spend their nights wrestling with petabytes of raw data. They feel the connection, the thread linking the Big Bang's chaotic birth to the precise calibration of a photodetector in orbit. Science, when viewed through this lens, sheds its reputation as dry calculation. It becomes a high-stakes emotional journey where relentless curiosity battles the crushing weight of cosmic indifference, illuminated only by the fragile hope of understanding. Ultimately, whether a deliberately constructed cosmic grand library exists, an artifact of intelligent design encoded in the most powerful physical phenomena, or whether the structure we observe is purely the elegant, yet chaotic, signature of natural law playing out across cosmic epochs, the contemplation itself yields profound dividends. The concept compels us to perform the essential human act, to crane our necks toward the infinite darkness, to feel the chill of the wind as a reminder of our fragile existence on a small, wet rock, and to dream of the secrets that remain veiled. The universe is not the empty, dead void of early cosmological models. It is an open, infinitely complex book, and the gamma rays, in their terrifying brilliance, are pages written in fire. Our imperative, our inherent drive, is to continue the painstaking translation, for who can definitively say what wisdom, what warnings, or what sheer poetry is encoded within that incessant, energetic whisper from the edge of time? The data flows ceaselessly, a universal conversation ongoing, waiting only for ears brave and patient enough to listen beyond the noise. The quest is not just to read the library, but perhaps, one day, to contribute our own volume to its endless shelves.